that everybody? Everybody in the room? All right. Welcome to Cloud Native Madison's July Meetup. I'm just gonna do, yeah, woohoo. I'm just gonna do a couple of quick notes before we get started here. We had our meetup last June on the west side. Thanks again to TeamSoft for sponsoring that. Hi, Clarice. Thank you. That was a great event. We held it at the Vintage. We will continue to rotate these events between east side, west side, and central. We may or may not be back at the Vintage, but we do plan to be back there in September, or back on the west side in September. So we put out a survey, and thank you to all of you who may have responded to that. The rotation on the west side was really well received, so we're continuing to kind of prove out our theory that if we can move this around town and make it as easy as possible for people to get to after work on a Thursday, that really makes this community stronger because we continue to see new faces coming out as we rotate around. We also had great feedback on Tyler Treat's talk. Tyler Treat from Real Kinetic, who gave an excellent talk on observability. And if you weren't there and didn't get a chance to see it, we do post everything on our YouTube channel of Cloud Native Madison. So go ahead and search that on YouTube if you'd like to go take a look at his talk. There's a lot of great stuff in there. Another thing that we continue to see in the survey comments is that there's a lot of interest in kind of a Cloud Native 101 night, and so we're starting to kind of talk about that in one of the upcoming months. Of I think initially the gut plan was to kind of like have these very high-tech talks, but we really want to make sure we're being an inclusive community in terms of skill levels as well. And so we're going to try to put something together so that even if you're not totally sure what a container is or what a Kubernetes is, you can kind of come and get your feet wet with all that. So look for that in the coming months. And then I do want to mention that our momentum continues to grow. So our first meetup was in March of this year. Last month, we announced that we cracked 200 members on our Meetup page, and as of today, we're over 260. So not only do we continue to grow, but we're actually continuing to accelerate the number of members we're bringing into this community. So we're really happy about that. We are planning August 1st having our Meetup at Arms Business Solutions, kind of our original location on the east side. We have one speaker lined up for that, and then our September Meetup will be on the west side, kind of TBD. So this means we kind of have maybe 2 to 3 speaking spots open, potentially. Oh, maybe we have 2. Yeah. In any case, if you're interested in giving a talk, even if it's not a 30-plus minute talk or whatever, please come see myself, Brandon Tim, or Kurt Rakely, sitting in the corner there, who's the co-organizer of this meetup group. So we try to do a quick, roundup of kind of what's been happening in the global community for Cloud Native at these events. And so the first big one is that CNCF has kind of started to bootstrap their special interest groups. And so you can see up there the kind of topics that these groups are forming around. And this isn't just developers and kind of the open source kind of product owners, if you will, within the community, but they do want participation from end users in the community as well. So even if you're not actually hacking on these projects, these are great ways to get involved, not only to kind of try to help steer the direction of these projects, but also just kind of keep up to date with where these projects are going. So there's more information out there on cncf.io. If they've kind of followed the model that Kubernetes has followed, they often have like monthly conference calls that like anybody can call into, just kind of hear what's going on within the SIG for that particular topic. And so it's a great way to keep your finger on the pulse. The other thing, big thing I wanted to call out is that Kubernetes 1.15 was released this past month, so that's cool. As far as being a user of Kubernetes, the one big thing that they added there was that their online volume expansion went into beta. And so for anybody thinking about or currently running sort of stateful workloads within Kubernetes, whether it's something like Prometheus or a database or anything where you have a persistent volume that you attach to your workloads, this really goes a long way towards making that more realistic, because before this feature existed, if you wanted to allocate a database, it was like, okay, I kind of got to assume how much I'll need, and then if I ever need to expand it, I kind of need to like take my workload offline to expand that volume. With this feature, you'll basically be able to say, my 100 gig volume now needs to be 500 gigs, and it'll just kind of handle that asynchronously for you in the background without having to take your workloads offline. So that's pretty cool. The other big kind of raft of features was around improvements for custom resource definitions. And so this is really all about the extension points and integration points within Kubernetes. And so many of the operator frameworks, for example, leverage this. And so this is really about improving and making it easier to kind of like hack additional functionality into Kubernetes itself. And then there's a bunch of kind of like local node improvements to help with local performance on those nodes as well. So not a huge release in terms of tons of new end user features, but just kind of wanted to highlight in case you don't religiously go read the release notes, what to look for in that latest release. So that's it for our monthly roundup. We do want to take the time to thank our sponsors. So the QTI group is sponsoring us today. They hooked us up with this beautiful location, which we're very happy about. So they're a full-service recruiting, HR, and consulting firm. Laura is in the room here, I believe, from QTI, along with a couple of her cohorts over there in the corner. So if you have any staffing or consulting needs that you might want to talk about, Laura's the person to see you for that. We also have American Family Insurance sponsoring the food for tonight's meetup, and as well as the two speakers we have tonight are from American Family, and so we really want to thank them for buying into our vision here, sponsoring us, providing some speakers. It's great to have them as a partner. So with no further ado, I'll introduce Nic Grayson, who's going to give us a talk about running Vault in production. Let's give him a warm welcome.
Did tell me. All right. So this is Hashicorp Vault, where I'm going through the basics and some deployment methodology and running it in production. So first of all, what is Vault? It's not the Kubernetes Vault. It's a totally different Vault. It's a product from Hashicorp. This is from their website. Just manages secrets and protect your sensitive data. And there's their gobbledygook that tells you that you can store everything you want in there. And then it has different ways to access it through HTTP, CLI, and UI. Let me move my cursor here. The biggest thing is that it prevents you from doing this. Here's a good example from Uber where this is on their public GitHub, and they just threw the database password in there. Somebody was nice enough to block out the host name, though. That was probably publicly available, too. So the first thing I'm going to do is go through a little bit about the features of Vault. But first I want to kind of do a survey of who has heard of or used Vault. So let's go with who's heard of Hashicorp Vault. Mike, you've never heard of Vault? Just kidding. And who has used Vault in production, not just testing. Not very many people. All right, that's good to know. Thanks. So there's different types of things you can store in Vault. A good example of this is your static secrets like API keys or database passwords for legacy systems that can't auto-provision new secrets. You can also do dynamic secrets, which is database passwords that have a Vault backend like MySQL, Postgres, Mongo. There's a bunch of other different dynamic backends. And then there's the list of plugins. Those are good examples. There's a big list on their website, and they change daily, so I didn't try to list them all here. You can also get full audit logs of everything that's accessed, each secret, when and why and how. So the first thing I'm going to do here is a quick little demo of a dev cluster, so you can kind of get an idea of what Vault can do. So first of all, we're going to do is just start a Vault. I installed Vault. It's just a little binary. It's a Go package. One more. Is that good? Yeah? All right. Vault server dev. Very easy to start. So now it's running. Oh, do I have to scale each one of these? That's pretty silly. All right. Okay, so now we can just export this. This will usually be, your nice Vault URL. Instead of actually having a root token, you can just tell it that your root token is there. And then now you can run Vault status. You can now see that it is initialized and it's unsealed. We'll get to that. Also, it's in dev mode. Don't ever try to run this with anything important. It keeps all of the storage and everything is just in memory. Which means every time it dies and restarts, it deletes everything. So not a great idea. If you're looking for resources on Vault, Seth Vargo is amazing. Used to work at HashiCorp, now works at Google as a developer advocate. He literally has a Vault demo website here. We'll go through some of this so we can work through what we're going to do. So the first thing you need to do is you actually log into Vault. So when you're doing dev, you can just log in, of course, to Vault. I think I'm already logged in. That's why it's Yeah, see, I'm already logged in. That's why it's complaining. It's fine. So he has this little script here that we'll go to. So this is just going to create some users in my vault. So now I've created Sally, Bobby, Chris, and Devin. These are just local users. You can also do different user backends like Okta, LDAP, Google, GitHub, etc. Now you can do something simple like a static secret. So here we're going to write the name of the secret, the location in the cluster is going to be secret foo, and it's going to be A equal B. So there we put that. It's now in there forever, until I restart it because it's dev mode. There's a get. When you do a get, you kind of get a hash of all the keys and all the values. So if I store in the same location, like C equals D, and then I do a get, you get whatever that current key and value is. So, which is kind of a weird thing. You can also do versioning. So we're going to kind of do these all at once. We're going to do a put of a new one, their CD. We'll get the new one, and then I'm going to go back and get the original version. So you can see the current version, which is version 3, because I've written it 3 times, is CD. You can actually see all the old versions of the secrets too. If for some reason your current one isn't working, you could get the previous version. You can also roll back if you wrote a secret that was bad. So there's a rollback. Now if I do that get, as you see here, here's the current one. It's back to version 1, even though it shows version 4 because I rolled it back. And then we'll go ahead and clean up to be responsible. So now if I do a get there, we'll get that there's a version, but there's no value. Another thing you can do with Vault that we don't currently do, so I don't have a ton of information about it, but you can actually do encryption as a service with Vault. So if you have some need to encrypt a value and then store it somewhere, you can use it purely for that. There's a lot of people in the financial industry that use this and get really high response times from Vault in order to do encryption as a service. Another really great part that we use a ton is dynamic passwords. So what I'm going to do here is I just started a Docker container that is Postgres. So you can see here's Postgres. It's just running there. And now I can enable the backend. Sorry, wrong. You have to actually hit copy. Wow. There we go. So now I have a database. Database now is enabled. You can see here, here's the audit log. This would be written to disk in your production cluster. I turned on the backend. I mounted the backend. This is what it actually does. So it's going to do vault write database config my Postgres database, and then it gives it the connection URL, and then this looks like Postgres commands if you've ever turned on a user. So now we're actually going to run that to configure the database, and now we just made a read-only role. So now we do vault read. So if you see here, it gives me my username and password. So if I go in, log in with that username and password, I get read-only to the database. So now those users I created earlier, we're going to pretend that we're Chris, and we know his password, and it's really super safe. So we're going to go ahead and log in. Instead of root, we're going to log in as Chris. So now we have a policy. So the biggest thing with Vault is you can have a set of policies that define what that user is allowed to do on certain paths and in certain backends. You can define everything you need to in policies to keep everything, that principle of least access. So this responds with a token. This is important. When you do Vault login, it does this for you, but sometimes you need to get your token, and you'll have to manage that inside your code if you aren't using a Vault library or something like that. So now what we're going to do is get that read-only cred. See, we had this write up here, and now we're going to do it as this user Chris. So you can see now I get you can see we actually get the exact same password because it has a certain time to live value. Oh, it's actually a different password because it's different every time. You get a lease, so that password's good for 15 minutes. If you're doing something that has a sort of Vault client, like using console template or something similar, you can keep renewing that password, so it's good as long as you maintain an active connection to Vault. If you lose that connection and your lease goes away, that password is deleted from the database. Vault handles that for you. That's part of the dynamic secret handling. So now we'll go back to the root user. Why is it doing that, man? All right. So what I did there is just made a bunch of database credentials. And then if we actually log in with PSQL here, we can now do the list of users. Now you can see I made all these passwords, and it shows you there's an attribute that tells you how long it's good for. Vault automatically adds that to let you know how long the TTL is. So now we can quit. And then now, if we've determined that, like, let's say the application is done, like it's not using Postgres anymore, or the user leaves the company or whatever, we can actually go and delete all of their, revoke all of their tokens. If I was logged in as root, it would work correctly. It's not, sometimes dev mode is dev mode, you know. And then you would be able to see that that's gone. And then you can revoke all of the leases. So that's what this actually does. So this would delete all the leases that Chris or Devin, those specific users, had. So that's every session they had. It would essentially wipe out all their sessions. And if you do a revoke on this prefix, it actually revokes every single lease for that database. And another part you can do with Vault is actually just seal the Vault. So if anyone who has access to unlock the Vault at any point in time can just decide to just turn it off. So you just make it offline. And that's if you think there's an active attack going on and someone's inside your network, you can just turn it off. And now no applications are allowed to get new passwords from the Vault. So that's kind of a good break glass sort of thing that you can do. There's also a large plugin architecture for Vault. So you can do whatever you can think of. You can probably write a plugin for Vault to have different storage backends or different dynamic credentials, etc. Okay, so there's my quick demo, right? So now we'll go through what you might need to know in order to actually run it in production. So the biggest piece here is storage. Dev mode runs it in memory. That's not a good solution. So you need a durable backend. Some examples are Console, which is another Hashicorp tool, which is a clustered key value store. When you use Console, in any of these backends, it encrypts everything based on their Shamir encryption algorithm, and then stores it in whatever backend it might be. Using something like Console or etcd gives you automatic HA. So if you run multiple Vault servers, they actually use the locking system that's built into locking and semaphore system that's built into Console. So unfortunately, like S3, you don't get HA automatically because it doesn't have a locking system. But you can also use etcd. So if you are managing your own etcd cluster, you could use the same etcd cluster for Kubernetes as you did for Vault. There's a bunch of different ones. You can check their website. They add a new one, it seems like every month. But Console is what we use, and that's a good recommendation from them. And then another important part of Vault is sealing and unsealing. When you do it in dev mode, it auto unseals, which means it's just ready to use to write and read secrets. So what you do to actually unseal a Vault, when it comes up, every single instance that comes up, so if it's on in Kubernetes or however you're running it, every time Vault servers run, each one of them individually has to be unsealed. And you do this with Vault operator unseal, and then you give it a certain unseal token that's provided to certain users. So they have an algorithm that allows, let's say you have a team of 10 people that you want to be able to have access to Vault as operators. You can say 3 of them need to be able to be there in order to unseal the Vault. So one person would do it on each instance, and then each person has to go and unseal it. Once it hits that threshold, then the Vault is unsealed and the secrets are ready to be used. If that Vault server is restarted for any reason, it needs to be re-unsealed, which has been a big headache for a lot of people running it on Kubernetes or something similar. If your pods get relocated, it'll come back up comes back up sealed, and then you have to manually go into each one of them to unseal it. They do now have an auto unseal that can use something like a KMS key and an S3 bucket to automatically read that unseal thing. And that is well documented on the website. And that's what we do. We do auto unseal with KMS and S3 so that we don't have to worry about the auto scaling group destroying servers and coming back up. Another thing that's important is authentication. You can use various OpenID tools to authenticate. You can also just write local Vault users, which is what I did in the demo there. The nice part of this is you can use your exact same login to get access, and then the groups that you might be in inside of whatever authentication system can be mapped directly into policies, so that when a developer logs in or an operator logs in, they get different access granted to them automatically.
How do we do it, Nick, in our team? We don't front-end it with Okta, do we? Do we just share a token because we're small?
No, we're moving towards Okta. Right now we have short-lived root tokens that we use and generate, but that's usually because we're doing operator level stuff.
Right.
But users, like when we move our data scientists over, we're going to be using Okta to log in and then have access to individual secrets.
Okay.
You can also do authentication methods of like Kubernetes. There's a plugin for Vault that does that. You can also do IAM. So if you have a certain role, then you're allowed to get a token automatically from the Vault server. So there's different ways to deploy. A good example, and Seth has given tons of talks on, because he works at Google now, so he's very into making Vault run on GKE. So there's an example if you do that. I'm not going to go through it. It was a 3-hour class I went through at Hashicorp a couple years ago. You can get through it there. This is what we use. This is a Terraform module that's released by Hashicorp. They have a few different ones here. There's like Terraform, AWS Console, and Nomad and Vault. So if you any of those, they have pre-made, maintained modules there. And then you can also, a newer thing you can do is a Kubernetes operator that will launch a Vault cluster for you there. And then for our actual deployment, we went through a few different things, and we settled on doing console and Vault with custom AMIs. So it just has Vault or console, everything it needs pre-installed in the AMI, just launches in an auto-scaling group. And then it's just use supervisor D to maintain just the binaries that are running. That's how Hashicorp deploys all of their stuff, is just simple Go binaries. You can also do them in Docker containers. We just decided to keep it very simple. And part of the reason for that is we needed console and Vault in order to launch the rest of our Terraform stack, which included launching EKS clusters. So it's kind of a chicken and egg problem there. We went with just having Vault and console ready before anything else got launched. And we also do private link. So we have kind of a setup that has a bunch of different Amazon accounts. There's kind of a shared services tools account, which runs a usable cluster, console and Vault cluster that's used by any team that wants access to it. And then we use private link to expose them through the Amazon intranet, whatever their backbone that goes between data centers. And so that requires you to have a network load balancer, and then you expose your services through private link from the tools account, and then you allow whatever other Amazon accounts to connect to it. Then there's some Terraform that runs that actually manages the connection. But that was not working great through Kubernetes because the network load balancers randomly assigned. The Terraform then wasn't able to search for it, and it was easier just to run it with no Kubernetes at all. There we go, the fun joke, right? Does anybody have any questions about kind of how we decided on deploying Vault the way we do, or how we use it? Gordon's going to cover a lot of this later with regards to how we connect our Kubernetes cluster to our Vault. So don't ask me, ask him for those. Yeah, go ahead.
Are you guys using the policy management features of Vault?
Yeah, you have to do policies in order to allow any user to have any access to anything. So by default, there's no access. Unless you're the root token, then you get all access. So yeah, we do. When you authenticate through Kubernetes, you get access to a certain policy that gives you access to certain paths inside the Vault. Yeah, go ahead.
What does the ongoing maintenance look like? Are you having an update on a really regular basis, and do they support kind of online rolling upgrades for that service and things like that?
Yeah, they're very good about letting you know when there's breaking changes, and there haven't been any since we've been running it. So when we upgrade, all we do is run a new, build a new AMI. Since we have auto unsealing, we just then one by one roll the auto scaling group, and there isn't ongoing issues with Terraform in doing that. There's this really cool tool called Bouncer that's open source you can use to roll your ASG, and you can hook that up to your Terraform. So when we build a new AMI, when we run the Terraform, it has null resources that will go and like kill each one of them as it goes through. And then it comes back up, unseals when it's available, then the next one rolls.
Secrets V2 change was kind of a pain.
Yeah, we did have some issues with like Vault released a second version of their secrets storage, and most of what that did was change some paths, which meant that application code needed to update with it. And then console template lagged behind that change, which is a tool that we were using at the time to grab secrets out of Vault. And then that kind of console template is a way that you can use Go templates. It then connects to console or Vault and then renders the files. So if you're using something that doesn't have, like you can't read from environment variables or whatever, you can use console template to render it. We use that for how we get our tokens to run our chat ops bot. It grabs its tokens and stuff out of console and Vault. And uses console template in the front.
Were we able to stand this up with using Terraform module registry and not have to customize any of our specs, or is our installation a little bit customized?
That default one is pretty good, the module, but we have like some weird tagging restrictions, and tagging is now improved drastically in Terraform 12. So we still are running the forked Terraform 11 module. But when we move to 12, we should be able to use that one without having to change anything. Do you have a question in the back, too?
Yeah, did you look at console or decide on console for HA specifically, or?
We were already using console, so we just decided, we use it only for key value store. But there's quite a few apps that support using console. Like if you're gonna use traffic as your like ingress controller for Kubernetes, it has really good support for using console to store its entire config. So it's good for that. It was also, we just wanted to have a highly available key value store that we could expose to our other users of our like lab environment. Also, it's the one that has the best support from Vault because they write both of them. So that's a nice part about it. And we use EKS for Kubernetes, so we don't have access to the etcd cluster. So I needed to run something. I did experiment with running my own etcd or console on top of EKS in order to then run Vault inside of Kubernetes. That just ends up being a giant headache, and it's easier just to make an auto-scaling group. Like they literally run on T2 nanos, so they cost us, the whole cluster is like $30 a month. And that's like, it's very performant, so we don't need, like we don't have that big of usage of it relative to some other companies that might, and it scales really nicely. So like console, you can make it 5 or whatever odd number, so it keeps its quorum correctly. It scales nicely, so does Vault. The Vault HA is kind of interesting too. Since it uses locks, you do actually all your writes to one, and then all your reads are distributed. So it doesn't have to proxy the reads through, which is kind of a good way to do that, because you're going to read more than you're going to write from most Vault services.
So we're using Vault for a lot of our application secrets, API keys, all that stuff.
Yeah.
And there's always an interesting question of, my developers would love to be able to use Vault to store their random bespoke secrets kind of in their own namespace for that application,
Yeah.
that service. What are you guys parking in Vault? What are you not parking in Vault? Are you using anything else that you have chosen not to use Vault for? I don't care what you're using. I'm curious,
Yeah.
is there stuff you've decided not to bring to Vault, and if so, why?
So if people want to,
Blank canvas of what the product can do. So.
yeah. So the enterprise version has namespacing. So that's actually a big selling point for the enterprise version. We don't use the enterprise version currently. We're looking at it, but we haven't done that yet. Each user can have their own cubbyhole, which is their own, that's a backend that's enabled by default. So if users want to store their passwords in it, they're allowed to do that. They just auth with Okta and then can put things into their cubbyhole. If it's for a specific application, there's no reason why wouldn't they have access to write secrets? Like, why not throw it in there? So if you need to store anything you want in Vault, like we allow the people access to write their secrets to Vault. What are the other solutions you're using aside from, do you have like enterprise LastPass or something, or?
Yeah, we do have enterprise LastPass, but not for the a lot of things are stored in secure S3 buckets. And there's an interest in just kind of normalizing on one secrets to store, but that's, it's a namespace question. It's a matter of
Yeah, one way to get around it is just to run multiple Vault servers, which kind of sucks.
I'm not concerned about the namespace because the RBAC can control what namespace.
Yeah, as long as you
Put
do
up another sequence
pathing, yeah.
namespace.
We were thinking about moving everything from console into Vault because it was performing so well. Why would we have two different paths that we have to do? We haven't done it yet, but to your point, we haven't found anything not to throw in there yet.
Yeah, like I don't think there's really a size limit. Like you can put like giant tar GZs if you really felt like it. You could throw them in there. I mean, probably not, but you could. I mean, remember you're gonna pay for it a couple times because it goes into console. It's gonna hit your backups, all of that. Another Vault Enterprise feature that's good is it does really nice disaster recovery for you, and it does multi-region stuff a little bit better than the open source is. But those aren't current concerns for us. So, anybody else? Yeah, go ahead.
So you brought up DR. We do DR right now.
I'm sorry, what?
Since you brought up DR, what is your current method?
We back up console, and then we also, all of our secrets are stored in a repo that is encrypted and then thrown in S3. So like we can recreate all the secrets if we need to. There's a really good blog post on the Hashicorp blog on Terraform about, they have this kind of weird bash script thing you can do with kind of paths and how it like can recreate all of your policies and everything from it. And that's a way that you can do kind of like, it's not really disaster recovery, it's like complete recreation. So that's one way to manage it if you don't go for the enterprise functionality. But obviously that's less secure than doing proper DR. Did you have a question back there too?
Yeah, is there any potential security implications to the auto unsealing, like Kubernetes environment?
Yeah, there is. If someone has access to that KMS secret, they could run their own Vault cluster itself, and then point it to the same location. We specifically isolate it in a tools account, and then we limit access to who can get into the tools account at all. So that's only the operators even have access to that AWS account at all. They do talk about the like pros and cons of unsealing, and if you're really in a high security area, it's way easier just don't do auto unseal, and just do it yourself. It doesn't go down that much. Like I think before we had auto unseal, I had to go and unseal one instance once in 3 months. Like that's obviously just an anecdote, but you can also do, there's console health checks on Vault as a service. So if you use console, it registers Vault as a service, and then if you're using console for service discovery, you can just resolve vault.service.console, and that's your URL for your Vault cluster. And it has a health check that checks if it's unsealed. So then if you hook up your monitoring system to your console health checks, you can get a page when it's when one of your Vault servers comes up as sealed, and then you can go and have your operators go and unseal it each time. And they can run those commands from their workstation as long as they have network access to the Vault server. So it's not too huge of a deal to not do the auto unseal. So if you're in a more high trust, risky sort of cluster, it's probably worth it not to do the auto unseal though.
We actually park our Vault servers behind the load balancer anyways, so if one of the three goes down, the load balancer just takes it out of circulation. We're notified that that was sealed. The consumers are normalized.
Yeah, and it's the same thing if you're doing the service discovery with console, it's only going to return the DNS records for the ones that are healthy and unsealed. So yeah. You get some weird load balancer issues though based on the way the Gaza protocol works, so it's always better to use some service discovery instead of using a load balancer. I get it though, we do it behind a load balancer too. So it is an NLB though, so it works a little differently. So it's more directly to the instances instead of relying on an external health check. All right, if there's no more questions, then I think that's exactly my time right there.
Yeah.
So I have 36 slides in 20 minutes. We'll see how this goes.
Nick ripped through about 50 slides in 5 minutes, so.
Yeah. Some of the slides are like duplicates, though.
It's good to have redundancy.
What's that?
It's good to have redundancy.
This is AJ. That's your PowerPoint, AJ is it back up?
Scale.
Should go down.
I'm using a console backend.
There's 3 laptops.
As this goes on, anybody let me know if like my head casts too much of a shadow on the screen.
Is that,
Because I might get up and walk around, so. We're good to go? All right. I titled my talk Aspect-Oriented Deployments with Kubernetes, which is a mouthful, so the simpler version is how to use Vault in your kube apps. The last one was more Vault from kind of an operations standpoint, and this one's definitely going to be more from a dev standpoint. So who am I? I'm Gordon. I'm a cloud engineer, work at AmFam. We do most of our stuff in AWS. I've worked with a lot of languages. Lately, it's mostly focused on Python, though. And we've been using Kubernetes for about 6 months. I'm part of a group called the Data Science and Analytics Lab, or DSAL, and we work 2 blocks that way. So the goals of this talk is basically I want to connect an existing app that I have that's running in Kubernetes to the Vault server. And I want the Vault server to give it its secrets with minimal changes to my app. Because as a developer, I don't want to have to add in a bunch of libraries and do a bunch of stuff. I just want, path of least resistance. And so starting assumptions, I want things to obviously be secure. I want things to be easy. The code has to still deploy to kube. Here's just some sample YAML. Maybe I'm deploying my cool web app with just a pod spec like this. And I want to have minimal changes to my code, minimal changes to the deployment YAML. So starting state, so my code has secrets and maybe non-secret config information that gets injected as environment variables. It's a very common pattern. I'm sure you're all familiar. And so, like I said, Python, you may just do something like this in your code where you say, get me the environment variables called username and password. And then somewhere in your pod spec or somewhere else external to the application code itself, you would provide those credentials. And so there's a couple naive approaches you can take to solve this problem. One is you can use the native Kubernetes secrets. There's an object type in Kubernetes called secret. And why is that a naive approach? Does anyone know?
It's not secret?
It's not secret at all. So Kubernetes, by default, stores its secrets in base 64 encoding. So anyone with access to the cluster, other apps in the clusters can read those secrets, and there's no encryption involved at all. It's just encoding. There are KMS plugins for Kubernetes that you can use that make that better, and that's an alternate approach to what I'm about to present. But this one I think is pretty cool and has some other advantages too. Another approach you can take is just add a Vault client to your code. In your Docker container, add the Vault client and have some startup script in the Docker entry point. And you can certainly do that. That's valid. I just think it's heavy, and then you have to do that to every single app that you deploy. I mean, you can use a base Docker image to do it, but I didn't want to do that. I felt like it was too much work. And alternatively, you can add the Vault SDK in your code directly, but that's even worse in my opinion, because then it's not, your app, you have to do a lot more. So if you wanted to add the SDK, like in our Python code, you would go from something like this to something more like this. And this is actually a highly truncated version of it. So I prefer not to do that. That's what I just said. So AOC to the rescue. That's AOC. I meant AOP. AOP is aspect-oriented programming. Here's the Wikipedia definition of that. It's basically looking at cross-cutting concerns and modularizing code to handle cross-cutting concerns. Cross-cutting concerns are anything that doesn't belong to an individual service. So both your user service and your transaction service and your record service, they all may need to do common utility functions like logging or metrics, or in our case, authentication, which is where Vault comes in. And so Java has really extensive examples of using AOP. The best example is probably Spring Security. For those of you familiar, you can write your methods and then just add a @secured annotation. And then as long as you have the Spring Security framework set up, it will ensure that any access to that method is restricted to whoever's allowed access. And so you don't have to write any fancy code yourself. You can just say, I want this secured, and I want only these people to see it. And so I'm trying to take a similar approach with Vault and Kubernetes tonight, as you'll see. So Kubernetes has a concept of annotations too. Earlier I showed you my pod spec. You could modify this to add an annotation to it. And annotations are just key value pairs. They can be whatever you want. They do have a kind of recommended format for what the keys should look like. It's basically like a domain path. But you can put whatever data you want in them. But out of the box, they don't really do very much. You can query your pods to see which ones have certain annotations on them, but what do you do beyond that? But they don't do very much unless you tell them to. And so the way that you tell them to is using another resource type in Kube called webhooks. And there's two types of webhooks, validating admission webhook and mutating admission webhook. There's going to be a lot of mouthful words tonight because they do that. So webhooks are basically just a function of inputs and outputs. And so it's a web service that runs, and you can run it internal to your cluster or external, which is what we're doing right now. And the input is the pod spec that's about to be created. So if you're going to deploy something in Kube and you've registered a webhook handler, it will send the full YAML to this webhook service, and that will presumably do something with it and provide an output back to the Kube controller. So the input is a pod spec. The output is a little bit different for the validating one versus the mutating one. The mutating one is actually a superset of the validating one. And so whenever you go to deploy, once you've configured the webhook, when you go to deploy, the Kubernetes controller will send it to this service and wait for a response, and no pod will be created until that gets that response. Then it will either proceed or not. So the validating one is very simple. You give it a pod spec, and then based on whatever custom business logic you write, you basically return a Boolean flag called allowed, which is true or false. And if you set it to false, the pod that was being asked to be created will not be created. Very simple. Kelsey Hightower has a example of setting up a simple validating admission webhook on his GitHub in GKE. He uses the GKE function as the webhook service. It's a very easy tutorial. I have it in the links at the end of the presentation. A mutating admission webhook does more than just validate. You can actually do the validation part with this too, but it can actually modify the pod spec that was passed in to whatever else you want. And so at this point, I wanted to just take a moment to talk about how I came up with this idea. So there was a really well-written article on a company's website called Bonsai Cloud called Inject Secrets Directly into Pods from Vault. And what I'm talking about tonight is exactly what they did. It's totally what they're doing. They actually have an open source thing that does this. I tried to get it working. I failed to get it working, and so I ended up just implementing it all myself. And I found it was both a good learning process, and it allowed us a lot more control and customization for what we wanted it to do. It's really not that hard once you get your mind around the couple of concepts. But you should definitely check out their article. It's very extensive. They have a whole repository that's written in Golang that can do all the same stuff. So the roadmap for what I want to accomplish is we're going to write a mutating webhook, aka a web service, that when it receives its input of a pod spec is going to look to see if a certain annotation is there. And since we're writing this ourselves, we get to choose whatever annotation that we want it to be. We're also going to write a helper binary that gets packaged in a Docker image that knows how to talk to Vault. And I'll touch on that in a moment. What's going to happen is if the webhook detects the presence of this annotation on an incoming pod, it will add an init container to that pod spec. And an init container, most deployments that you do just have a list of containers, but A init container is a separate section in the spec that allows you to run containers before the main ones start to kind of do setup and stuff like that. And then I'm also going to change the pod spec at the same time to add a shared volume so that the init container and your main container that you're trying to deploy can have a way of talking to each other.
Would that init container be a sidecar?
It's very similar to a sidecar. The difference, technically a sidecar is a container that runs in your main container section, so it's like ongoing. But conceptually they're the same. It's just adding another container in your pod environment. The difference is that this one runs and terminates before the main one starts. And actually, that's a good point. If any of you who are using Istio, they do this. They use a webhook in Istio to add sidecars for the Envoy system to all of your pods. And those are just long-running containers, whereas init containers have to terminate. And then what we're going to do is the webhook will take in the annotation value and pass in that as a parameter to my init container so that it knows where to get its secrets from. And so I made a diagram of that. The input is going to be a pod with running one container and has an annotation on it. The entry point to this pod is my container. After it passes through the webhook, I decided to do a gray Docker logo for the init container. I don't really know how to represent these things visually, but there's a shared volume between the two containers, and now the entry point moves. This is another transformation that it'll do to a binary that I've placed in the shared on the shared volume. And then the command, rather than the entry point, will be what the original entry point was. Again, all of this is pretty well documented on that Bonsai Cloud article. I've also got a blog article that I'm halfway through writing right now about this. And so what's going on inside of that init container? I'm a developer. I'm terrible at naming things. So when I wrote this for AmFam, I called it envconfig. So that's my little helper application. And it has two functions. Envconfig init is what the init container calls. And basically what that does is it is given the value of the annotation as an environment variable. So the value of the annotation that I'm giving it is actually just a path. It's not a secret. It's not anything like that. It's just a path to where the secrets live in Vault. And I'm passing that in, then transforming it from an annotation to an environment variable in the init container. And so when it runs, it will write out that path to a file on the shared volume. And then it will also copy itself, the binary, to that shared volume and quit. Because when you create a shared volume in a pod, it's blank by default. So I have to copy it. And then the second thing that happens is if you invoke it with any arguments other than my -- init, it will behave differently. And so what it will do in that mode is it will search for the env file that would have been written by that point on the shared volume. Use that so now it knows what the path in Vault is. It will connect to Vault, query for secrets at that path, and then receive those secrets back. So all of the logic for connecting to Vault is not in my application container. It's in this separate sidecar container that I've written. And then what it will simply do then is taking that new environment, because now it has secrets, it will spawn a new environment with the original entry point. So it will launch my main container as a sub-process. And the benefits to that are numerous. Number one, we can restrict so that, one thing I could have done is that I could have just said my webhook can just can connect to Vault directly and get the secrets and add them in, and then I don't need a sidecar or anything like that. Disadvantage to that is that in your webhook, it has to basically run in God mode. It has to be able to get secrets for anything. And I want to restrict that down to just secrets for the pod that's running. And so by doing it the sidecar method, it's effectively coming from that same pod. So whatever method that pod would use to authenticate, we're using IAM roles for that. So it'll be restricted to whatever IAM role that pod is given, and this based on the Vault policies you set up. Secrets aren't.
You're also doing that for console, right? Because you're merging those, and as far as, let's say, my web service application code doesn't distinguish between Vault and console. I'm looking at env farms by a key value, and you are merging console and Vault based on the same path and injecting into my container, right?
Yeah. So for this talk, I kind of left off a couple of details of customization that we did. In reality, we made this a little more robust, where not only can we pull Vault secrets from Vault, we can pull configuration data from other sources as well. But for the purpose of this talk, don't worry about that. So on the topic of secrets, because we're not writing the actual secrets themselves to disk, we're just writing the path where they live to disk. The secrets aren't stored on anywhere on the shared volume. So even if a malicious actor got into this pod, they wouldn't be able to see them. They're also not in the shared memory because it's launching the sub-process directly, not setting the external environment variables. So it really is self-contained and secure. And then the other benefit is you don't have to change your application code at all. I can continue using my os.getenvironment username password, and then we're good to go. Cons is all of this is really complex to set up for the first time. Once it's good, you're good. And then also, what I discovered is that the webhook code needs to be flawless because every deployment that you do in Kube is going through it, whether it's a pod or a service or whatever. So if it errors out on anything, you're going to have cascading effects downstream in all of your Kubernetes stuff. So that code has to really be solid and really well tested. Because I was working kind of in sandbox environments, but what happened is that it was not well tested, and so then things kept breaking. And so now it's quite good, but when I was first writing it, there's a lot of headaches.
What features in Kubernetes when it invokes the webhook and let's say you would return, let's just say a 500 to Kube, can you abort and shut down and log and provide any type of notification if, for example, that webhook fails?
So the article that I mentioned from Bonsai Cloud, they talk a lot about making sure that you keep this all internal to your Kube cluster. Don't do any external webhooks, which we totally do. And also enforcing TLS between the webhook and the pods that communicate with it and everything like that. So I deployed it to Lambda because it was easy, and also because I couldn't get the Bonsai Cloud thing working. It is over, Lambda, it's fronted by API Gateway, so it was over TLS already. And the benefit to that is that I've had a lot of trouble consistently getting log messages out of Kube. I've constantly had headaches with that. And the nice thing about Lambda is that everything it does is just there in CloudWatch. So for setting this up for the first time, it made a lot of sense just from a development perspective. I think it's secure enough. I think over time, I may move it into a long-running pod, a service that runs inside the cluster, and really start cranking down the security dials on it, or cranking up. But for all intents and purposes, it was a lot easier to do it through Lambda because then I have that immediate insight without having to filter through the kubectl, get logs, and all that sort of stuff. I did want to talk about some specifics of the code that I found particularly challenging when I was writing this. So all the articles I could find on webhooks didn't really touch on this, and so there was a lot of painstaking trial and error to finally figure this out. So the response that your webhook has to send back for a mutating webhook is really frickin' weird. There's not much to it. You give it the UID of the request that was passed in. You say allowed true, and then you have a patch object. But the patch object was not well documented at all, and so I'm telling you now, so to save you a couple steps. The patch document will look like something like this. It's a base 64 encoded string, and so if you look at that, excuse me, what is it? It's actually JSON. So rather than using the JSON that you're already in, they put the JSON inside of a base 64 string inside of your JSON. So just word of warning. So what JSON is it there that gets encoded? It's using a standard called JSON Patch, which involves 3 operations: add, remove, replace. So keep in mind this webhook, it's patching your pod spec. In the pod spec, you're typically writing in YAML. But YAML is mostly isomorphic with JSON. So you can translate one-to-one from YAML to JSON. So for all intents and purposes, your pod spec is JSON. And so you're using this JSON patch syntax to change what's there. And you can do any arbitrary changes that you want. You don't even have to really build something that's based on annotations. You could just as easily do it off labels or other or image tags or anything that's in the pod spec. There's no sacrosanct marriage between webhooks and annotations. It just seems to be the one that makes the most sense. And so the JSON patch is represented as a list of patch operations. And then that list, so it starts with the square brackets and ends with them, and then you base64 encode that, they look like this. So it's each entry in the list has 3 values, operation, path, and value. The operation is either add, replace, or what was it? Remove. I'm not using remove because that wouldn't make sense. So the resultant base64 string is actually quite long because I'm doing like 4 or 5 things in my webhook. I add in a volume mount, and you actually have to check, I have a couple simple if statements, like if the volume mount section is already there, replace it with this. If it's not there, add the volume mount section. It has to be, my point there is just you have to write resilient code. So I add in a volume mount to my existing container. I add in the volume definition. I change around the entry points and commands. And that's another thing that's really confusing about Kubernetes versus Docker, actually. So in Docker, you have entry point and command. In Kubernetes, the exact equivalent of that are command and args. So command does not mean command. They cross the streams. And then the bigger one is that I just add in a new init container. And this should look very familiar if you've written any deployment YAMLs. It's just basically a JSON form of the deployment YAML. So I'm running my env config there. So I spread this out over 5 slides, but it basically will spit out all that, base64 encode it, and put it back in the original message. All right, so it's demo time. Let's see. All right, so I'm doing kind of a simplified demo because I was using some stuff that has actual secrets that I don't want to share, so I had to work around that. So let's see, am I connected to Vault? Yes. So Vault. Okay. Oh, I actually didn't even use those. So let's see. Actually want to start here. So I don't know if this is, if you folks can read this, but what's the, there we go. Okay, so I wrote a simple web app called env debugger. All it does is serves up an index resource that shows you what environment variables it knows about. And so I'm going to first not do any of this stuff that I was talking about and just pass in a simple environment variable there. And so let me run this one. So if I say this is without the fancy stuff. Oh, I'm in the wrong folder. Yeah. Am I in what folder? Oh. Okay. And just gonna wait for, okay, that is up. So if I do some port forwarding so I can access the service from the cluster. How do I get out of this? There we go. Let's see. Here we go. So it's just a simple JSON object containing all the environment variables. So you can see I passed in an environment variable of favorite pizza, and that showed up there. But I want to be able to use what I was just talking about to connect to Vault and pass in everything like that. And so let me first kill this, and then get rid of that. So that's another thing I want to mention is that the way this works, I configured the webhook to run on pod create, not on pod update. You can configure that, but the way I did it is I actually have to fully delete the pod to make it work before, and then recreate it, just because that's the entry point for the webhook that I gave. But that is configurable. And so let's see, back here, I have a change to my YAML. So this is essentially the same YAML. The only thing that's different between these two is that I add in 2 annotations. And I'm piggybacking on top of an actual product we have called LeadGen. But what I'm telling it here to do is connect to our Vault server the database credentials, so the dynamic database credentials that Nick was talking about earlier, using this username, which exists in Vault, or this config name, and then using a specific role to do it. This is the Vault role, not to be confused with the IAM role. So I need to pass in, it's a bit of a misnomer when I was saying you can do this in just one annotation. I actually need to do at least 2. But this is, from an application development standpoint, this is actually really nice, because if that's the only changes I have to make, it's really nice. And so let's see, if I just apply that, give it a second to spin up. It's ready, okay. And then port forward again. So I have changed nothing about my application code. I have changed barely anything about my deployment YAML. And now when I go back to see this web page, you'll see that it's a little bit longer, because all of a sudden I have this username field, which is a real username to the development LeadGen database, and a password field, same thing. It's only valid for 15 minutes, so I'm not too worried. But from like I said, from a development perspective, that's very slick. I hardly had to do any work as an app developer to suddenly inject secrets. And I have another version of the annotation where I can say, and then it would be decel LeadGen R&D. And that will grab any secrets that are at that path, because you can have multiple secrets assigned to a single path and inject them as variables too. I'm not going to do that for this particular one, because there's some real secrets that I don't want people to see. And I couldn't, I was rushing to get my presentation done, so you have to set up a couple things to get it to work behind the scenes in terms of Vault policies. So there's some associations between policies and roles, and I didn't get time to do that. So we're just seeing the database one right now. But trust me when I say that if I added in that third annotation, we would see even more environment variables show up automatically. And so let's see, back to this guy. So word of warning is that if I want to empower developers to write webhooks that can do really cool things. It's not necessarily just connecting to Vault. As my colleague was touching on, we actually wrote it to connect to Vault and console and do some other things as well. It literally is an input-output of, like, give me a pod spec, and I can transform this pod spec dynamically into whatever I want it to do. So maybe you want to have some memory scaling thing that happens, or it's truly, the mutating admission webhook is a truly powerful tool in Kubernetes. But it's also dangerous, because if you do something wrong, you can have a lot of downstream negative effects to there. So use it wisely, but don't be afraid to use it. So some more reading. I'll leave this up here. There's a couple articles that I referenced for learning how to do this. I did actually write a blog post about this on our AmFam Labs website, but that is actually only accessible to people on the American Family Network. I'm in the process of creating my own consulting website, and I'm going to have a same version of that blog post that's cleaned up a little bit for public consumption. It's just I didn't have it ready for today, but hopefully within the next couple of weeks I will have that live on my consulting page. Follow me on stuff. I'm from DSAL. We do some pretty cool stuff. Thanks, guys. Questions? Yeah.
I'm just curious, so how big of a developer base is kind of using Kubernetes with that integrated? And the reason I'm asking is because one of the things that is kind of made me nervous about implementing more mutating webhooks is kind of like a developer doesn't fully understand that mutating webhook and what it does, and so now you're kind of like pulling the rug out from under them in terms of like what they submit to the API server versus what actually happens in the background. So are you using this with a big base of developers, or is it a smaller base where everybody kind of well understands that this functionality is going to be added in on the way?
It's a small base for sure right now. That may grow. I hope it does. But yeah, it's been easy to manage just because it's been so few hands in there. Anyone else? Yeah.
Yeah, first off, that was awesome. Like, I can't imagine the challenges, but yeah, kudos. So the next question is like, how long did it take to do this? How many people? And what are some things you wish you would have done differently?
One person, maybe 3 weeks. Does that sound about right?
Maybe a little longer.
Maybe a month. Challenges and things I could have done differently. They're asking me to reflect.
You should have been on our weekly one-on-ones. You had a lot of challenges. It's hard. I mean, Kubernetes is just a cluster of itself. I mean, it's a beautiful piece of software, but
Yeah, so
it's huge, right? I mean,
Yeah.
it's a massive thing, so to figure it all out is...
So I mentioned at the beginning that I've been playing with Kube for only 6 months, and so this is pretty advanced stuff. And so I was learning this really advanced stuff at the same time that I was learning all the basics. And so for me, like, just getting consistent logs out of the cluster was a challenge. And so I maybe would have spent more time just getting used to the Kubernetes ecosystem first of all, and then in an ideal case, I maybe would have done what the Bonsai Cloud folks recommended, which was to write this as a service running in the cluster rather than doing an external Lambda for it. Although I don't feel too bad because in Kelsey Hightower's example, he does an external GKA function. But it is more secure to keep it all within the same cluster. I can't remember half the challenges that I would have talked about with Mike at this point anymore. So, but basically just get the fundamentals down first, get a good logging solution in place, and then write it as a long-running service if you can.
Yeah, I asked that in admiration. Yeah, thank you.
The cool part, and he's not going to tell you this, is that, and the other developers won't tell you it either, they overlook it because now it's so easy. We just assume it was a part of Kubernetes, and it's that native almost to that extent, so it's awesome.
Yeah.
Ask one more. I think I know the answer to this, but so is there any? Have you thought about it all? The notion of being able to sort of couple the versioning of the secrets that Nic demonstrated with sort of a deployment that's going out and grabbing these secrets, right? Because one of the things that we one of the things we really like about Helm, right? And
Yeah.
we do use Kubernetes secrets, which, as you alluded to, other than having role-based access control within a namespace, anything within those namespaces can grab those secrets. So it's certainly a little bit less secure in that sense from this. But
Yeah.
one of the things we like about it is that if a password is wrong and that was changed as part of a release, the entire thing can get rolled back to like the previous version of that secret.
Sure.
And so I'm just curious if you've thought about that at all, if there's any way to kind of couple the versioning of the secret to that deployment getting rolled.
That's a really great question. He's asking about coupling the version of the secret in Vault to the deployment or to the webhook. And I have two things to say about that. Number one is, from a security standpoint, I don't believe you can restrict access on versions. So, if the pod can get access to one version of the secret, it can get access to all of the versions. But from a deployment and rollback standpoint, that would be a really valuable thing to start thinking about. I think it would be possible. I mean, basically, since you're doing an arbitrary transformation on your JSON pod spec, you could include as an annotation or label or whatever you want some version that gets packaged, and then that's just a convention then that you have to promulgate to all your developers. And then you can make it so that if it will fail to do anything if the version is not present, and so then it will ensure that you have the latest and greatest. That does add the burden of, well, maybe it's not a burden, but I was going to say updating the deployment when you change the secrets, but maybe you had to do that anyway. Great question. Anyone else? All right, thanks, guys.